So I'm going to discuss something known as Boyles' law. Now, Boyles' law, what came up is a law that was come up by someone called Boyles, and it shows the relationship between pressure and volume. Now, air, gas, as opposed to liquid and solids, gas is actually compressible. Okay, you can compress gas pretty easily, but as you decrease the volume, so if I look at this syringe over here, okay, I put a finger stopping the air from escaping. So the number of gas molecules inside it stays the same. Okay, there's a lot of gas molecules inside it. It stays the same. So as I push the plunger, I'm decreasing the volume. Now, because I'm decreasing the volume, the gases are becoming squashed up more and more and more, and that increases the pressure. Remember, pressure is the collisions with the walls. So if they got less space, there's a greater probability that they're going to hit the walls of the container. That just increases the pressure. Now, what happened was he plotted the graph of pressure against volume. So as you can see over here, the pressure is the highest when the volume is the smallest. So a smaller volume, higher pressure. A greater volume, so if you space it out a lot, the pressure decreases exponentially. So it's not a linear relationship, exponentially, or you could plot 1 over the volume. When you plot 1 over the volume, is actually a straight line. Now, you don't need to memorize these graphs off by heart. The important thing is that you're going to have to know this equation. P1 V1 is equal to P2 V2. And this is, now this formula only works if you keep several things the same. The number of molecules, so you don't add in extra molecules into your container, as well as the temperature. Remember, as you heat up something, they gain more kinetic energy and then the pressure increases, blah, 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 blah. So you have to keep the constant temperature and constant number of molecules. That means whatever the P1 V1 over here is, it will be equal to the P2 times by V2 over there, because over here, let me show you. So over here, you got a different volume, right? You call this volume V2, and then your pressure is going to be P2, right? Over here, you got a specific volume, V1. It's really big, right? So then your pressure over here is going to be P1. So in both circumstances, they are going to be equal to one another.